Hello, this is Mr. Craig, and today I want to show you how to perform the Boyle's Law lab. A couple items that you're going to need. You're going to need a glass jar, bottle. It's approximately a 2.5 liter old acid bottle. You will need a funnel with a hose and a glass tube that has a rubber stopper on it. So it kind of looks like a funnel, and a clamp. The clamp is pretty important. So we're going to put that on a ring stand with a holder there. So I'll feed that back through again. And then what I want to do is make sure I know how to use the clamp. So I will clamp it shut, unclamp, clamp it shut, unclamp. We definitely want to know how to do that so that we can stop the flow of water when necessary. I'm going to need a tape measure, a regular ruler to help measure the height of the water, and one graduated cylinder. So the first thing I want to do is take the bottle and attach it to the glass tube that has the stopper on it. So I'll take the glass bottle and insert the glass tube with the rubber stopper and just firmly press down to make sure that the rubber stopper seals with the bottle. Here I've got the glass tube and the hose above. The next thing I want to do is add water to the funnel while the clamp is open and the rubber stopper is firmly affixed or on the bottle. Now the last thing I want to do is allow any air into the funnel once I start pouring the water. So at this present moment, the clamp is open, the atmosphere is exposed to the bottle. The bottle's already been pressurized because it was open to the atmosphere. So what I'm going to do is I'm going to add water to the funnel, which will then run down the hose, down through the glass tube, and into the bottle. So I will carefully pour the water. Once I start pouring the water, I cannot stop. So now that the water is being poured into the funnel, the water's passing down through the hose and it is moving into the glass tube, into the bottle, and the water is actually starting to flow a lot slower into the funnel. What is happening is as I introduce water into the funnel, thus into the hose, into the glass tube, the air that was in the bottle is now being compressed because there is water displacing where that air once resided. At this point, the funnel is full and there is no more water going down, so I will clamp the hose shut. As the water is being poured into the funnel, you can see that some of the water is going into the large bottle, and eventually what's going to happen is the pressure that's built up in the bottle is going to get so great that it's not going to allow any additional water to pour into the bottle. And at this point, that is as full as I can put in, as much water. So you'll see in the bottle how it is not allowing much more water to come in. And at this point, clamp it shut. And what I'll do is, after the water's been added, you can see that there's some water that's been added in here, and the pressure that the atmosphere originally was is increased. Even though that a little amount of water that's actually been added does increase the pressure inside. So you should hear a little, like a whoosh, once we release the stopper. So listen carefully. So there, the pressure has been equalized in the bottle. So I'll set the glass tube off to the side. Now I have some water that's in the bottom of the bottle, and I'm going to take some measurements from that. But before I do that, I want to measure the height of the funnel. So to measure the height, so what we want to do is we want to get a measurement from the height of the funnel to the floor. Actually, here. So, and I want to use the side that has centimeters. So I'm going to hold that there, and if my arms are long enough. So hold that there and not tip over the ring stand. So I'll get a measurement, and right there, that's exactly 129 centimeters for this measurement, 129 centimeters. So I would record the height of the water, quote unquote, hose or the actual structure. Then what I want to do is I actually want to measure the height of how high the water is. So I'll take my ruler, and what's kind of cool is there's a space underneath here where there's actually no measurements, and it starts, and that's about the same thickness as the bottle. So if you place the ruler right next to the bottle, it's pretty accurate. And in this case, it's the height of the water that's in here is 29 millimeters. So you would record 29 millimeters. Then the next thing you would do is you want to find out how much water you actually have in the bottle. So there's no way to look at, there's no measurements on the bottle, so you'll take your graduated cylinder and carefully pour into the graduated cylinder. And in some cases you may have more than 250 milliliters, so you want to be careful. Okay, so I still have some water in the bottle, but right now I am at exactly 250 milliliters. So I'll pour that out, and then I'll pour in the additional water that's in the bottle. And be careful, don't spill it, because you kind of need these numbers to help you out. Let's get all that water out. And I already had 250, and in this case, holding it up, it says that I have exactly 20. So the volume of the water that I had in the bottle after adding it to the funnel is 270 milliliters. So that would be the third measurement that you would write down on your data sheet. The fourth item that you're going to measure is what is the volume of the bottle. So what you want to do is you want to fill up 250 ml graduated cylinder with water up to 250 mils. I'm not going to do it. And then pour it in carefully. Then you or your lab partner make a tick mark. You're going to count how many times you place 250 milliliters of water in here until you get to this mark right here on the bottle. It's kind of got a little lip on there. That's where actually the stopper once stopped once you were putting this, because these were either hydrochloric or sulfuric or nitric acid bottles, storage bottles, and so it had a little built-in shelf / lip. So we want to go to that height there. So count how many times you're going to add 250 milliliters of water, and then go up to this point here. Now, it's not going to be exactly 2.5 liters like it says on the instructions. You won't write 250 milliliters, or I'm sorry, 2,500 milliliters. I want you to get the actual volume of that. And then the last piece of data that you're going to have, and the volume of the bottle won't change from trial 1 to trial 2, so that's kind of nice. The last piece of data that you're going to have to record is the barometric pressure. Now today's a sunny day, so the barometric pressure is going to be a little higher. If it were cloudy or stormy, the barometric pressure would be a little lower. But that information is going to be provided to you by your instructor. Hope this video helped.